Let's take a look at number 7. So we are going to determine the measured angle for A and also for B. So to do that, I'm going to start by making this triangle here. It's going to be my A and my B so that there's no confusion. Now A has a value, a sine value that's positive. Sines are only positive in quadrants 1 and 2. So I know it's going to be neither quadrant 1 or 2. And then it says the cosine of A is less than 0, which is a fancy way of saying the cosine is negative. Cosines are negative in quadrants 2 and 3, so the overlapping occurs in quadrant number 2. So my terminal angle is going to go straight out. This is my angle closest to the origin. Now it says that the sine is 3/5, so opposite over adjacent. I've memorized that's one of the most common Pythagorean triplets, but if you didn't know it, you'd say a squared plus b squared equals c squared. So 25 minus 9 is 16. Taking the square root, we get 4. All right, let's move on right now to C, or to angle B. All right, so we have a tangent that's positive. It's either going to be in quadrant 1 or quadrant 3, where tangents are positive. And the sine is less than 0, which means the sine is negative. We can see that overlapping is going to occur in quadrant 3. So I'm going to go straight out, back here. Let's figure out this angle. Tangent is going to be opposite over adjacent. Again, this is a famous or very well-known Pythagorean triplet. I know this is 13, but you could use a squared plus b squared equals c squared. 144 plus 25 is 169. That's how we come up with the 13. How do we answer number 7? Well, I'm going to first take my calculator, 2 plus 7, 1, 2. Clear it, go up to mode, and let's make sure we're in degrees. So let's start with the sine. I know that if I do the inverse sine of 3/5, I'm going to figure out the angle measurement for A. So angle A is 36.8. Let's look here. 36.8. I can cancel out these two options. And these, by the way, should have a little degree symbol, not a D there. Now let's figure out angle B. So we can do the exact same thing. Second tangent, so we have inverse tangent of 12/5, and we have 67.3. We can see our correct answer is option A. Now, I'm going to take another piece of paper here, flip it over, and we want to figure out what is A plus B. So let's go back and let's use this, A plus B. So I'm going to write this down. Now, I'm going to start by saying, okay, A plus B is equal to sine A cosine B plus cosine A sine B. These triangles we just created are really going to help us. Let's start with what is the sine of A. So this is A and this is B. Sine of A is 3/5. So first I'm going to write it down, 3/5. And then I have to ask myself, in quadrant 2, is the sine positive? It is. Now let's go to the cosine of B. This is B. So cosine is adjacent over hypotenuse. Adjacent over hypotenuse. Now in quadrant 3, we know the cosines are negative. Let's go back to A. What is the cosine here? Cosine is going to be adjacent over hypotenuse. And this terminal angle lands in quadrant number 2. And then in quadrant number 2, we know that our cosine values are negative. Let me grab another writing utensil. Put a negative symbol here. Now we need to do the sine of B. Okay, so sine of B is back up here. Sine of B, okay. So sine is going to be is opposite over hypotenuse. And I know in quadrant number 3, this is going to be negative. So I just want to make sure my signs are right. Since I switch writing utensils, I want to make sure I'm paying attention. Here's A, the sine is positive. Here's B, the cosine is negative. Here's A, the cosine is negative. Here's B, the sine is negative. Okay, here we go. Alright, so I have 3 times negative 1 is negative 3 over 13. Two negatives make a positive, and I have 48 over 65. Now I'm going to grab a calculator. If you couldn't use a calculator, you would definitely want to do the butterfly method to combine those two. We get 33 over 65. Our correct answer is A. Let's go on to number 9. Number 9, let me grab a new piece of paper. Number 9. All right, so I'm going to take back here, and I got to know what is cosine of A minus B. So I'm going to write down this fact. Cosine of A minus B is cosine A, cosine B, plus sine A, and sine B. All right, let's come right back to this paper. What is the cosine of A? The cosine of A is 4/5, and it's negative. What is the cosine of B? The cosine of B is 5/13, and it's negative. What is the sine of A? This is A. Sine is 3/5, and it's positive. What is the sine of B? Sine of B is 12/13, and it's negative. Okay, well, the 5 and the 5 will reduce to 1. A negative times a negative is a positive, and I'm left with 4 over 13. Positive times a negative is a negative, and nothing can reduce here. I have 36 over 65. I'm going to do the same thing. If you couldn't use a calculator, you'd do the butterfly method. So 4 over 13 plus negative 36 divided by 65. Turning it back into a fraction, we have negative 16 over 65. Let's find that. Negative 16 over 65 is option B. Let's look at number 10. I'm going to flip this around so I don't waste any paper. Tangent of A plus B. I'm going to write this down. Tangent of A plus B is equal to tangent A plus tangent B over 1 minus tangent A tangent B. Okay, let's look back here. Tangent A, so this is my A, tangent, opposite, over adjacent. So this is 3 over 4, and I know it's negative because the terminal angle for A lands in quadrant 2. Okay, what's tangent B? Tangent B is opposite over adjacent, so 12 over 5, but in quadrant 3, tangents are positive, 12 over 5. Now, tangent A, I already know this is negative 3/5, and I know tangent B is 12/5. Okay, I'm going to use my calculator here. I'm going to figure out the top. Negative 3/4 plus 12/5. Turn it back is 33 over 20. In the denominator, it's 1. Subtract negative 3/4 times 12/5. Turning it back is 14 over 5. And now I have 33 divided by 20 divided by 14 divided by 5. 33 over 56. Oh, looks like it's cut off here. 33 over 56. Option A. Let's look at number 11. 11, we're asked to find the exact value of the sine of 15. Well, when you look here, sine of 15, although it lands here right in between, we don't know exactly what that is, but I know that if I take 45 minus 30, which I do know these values, I'll end up with a 15. So I'm going to rewrite this as the sine of 15 degrees is equal to the sine of 45 minus 30. Let's call this A, and let's call this B. So I'm subtracting. I'm going to write down this formula. So it is sine A cosine B minus cosine A sine B. Now here's my A. So sine of 45 times the cosine of B, well, B is 30, minus cosine of 45 times the sine of 30. What is the sine of 45? The sine of 45 is radical 2 over 2. What is the cosine of 30? The cosine of 30 is radical 3 over 2. What is the cosine of 45? I know it's radical 2 over 2. And what is the sine of 30? It is 1/2. When I multiply, I get radical 6 over 4 minus radical 2 over 4. So radical 6 minus radical 2 all over 4. We can find that answer right here in option A.